Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Navaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib. I'm here with JP. How are you, sir?
I'm doing really well. I'm excited about today's conversation.
Yeah, this is one that we've been talking about for a long time and really excited to have our wonderful special guest, Dr. David Perlmutter. How are you?
Well, I am great. I'm feeling really well, and I'm very, very excited to be with you guys today. I think, knowing what you are both about, it really dovetails quite nicely with what I'm researching these days, and certainly with my new book as well.
Absolutely. And the new book is going to be kind of this topic that we're focused on today, which is brain defenders, specifically talking about the immune function of the brain and how immune cells regulate brain functionality. And I want to take a quick step back and discuss kind of your journey into integrative neurology and integrative through the functional medicine lens. Your journey has been going on for a little bit now, and you've...
That's for sure.
It's a nice way to say it, but you've been definitely at the forefront of this functional integrative world for some time. And the world is finally taking notice. And I think we're at a point where we can start to talk about the underlying biochemistry, underlying physiology to improve the function of the brain. I'd love to hear a little bit about your journey. If there were a couple insights, a couple moments where you really knew that this was where you needed to be in the integrative world.
I will say I can't, pinpoint the moment. Everybody asks, what was that epiphany for you? When did it happen? Do you remember the day? And I do not. But I just remember a significant level of frustration as a mainstream neurologist. It's basically taking care of people with established illness and really began to wonder, this was 35 years ago when the idea of preventing heart disease was really taking hold. And I thought, well, really the same mechanisms are at play in the brain: free radical mediated stress, inflammation, lifestyle factors that are inroads to those processes. Why wouldn't there be a body of literature starting to be developed that would be able to inform me as a neurologist how to keep people healthy from a brain perspective, knowing that it's already, getting traction in the heart world? And sure enough, doing that research was very revealing that plenty of centers were doing research already correlating lifestyle choices to risk for brain degeneration. And I was in the dark. I was basically in my neurology training taught how to deal with established illness. And I really felt like that's okay. It's noble, right, to take care of somebody who has an illness, but why don't we keep people healthy in the first place? And began to implement these ideas into my practice in terms of my messaging, and realized that I had to, at that point, really broaden the messaging part of what I do well beyond my patients for whom I was caring day in and day out, and began a radio program, a television program locally on cable, and really did my very best to get out the simple message that we are the architects of our brain's destiny. We really need to understand that we have agency, not just over our bone density and our heart health, that we have agency over the direction in which our brains will go for the rest of our lives. And even these days, it still rubs people, the hair in the wrong direction. The mainstream neurology wants you to believe, I think pretty much still, that live your life however you choose and we'll fix it with our newest pharmaceutical or technological approaches. And I don't discount the value of pharmaceutical research in neurological diseases. I think there's great value. But again, I think the real impact should be to keep people healthy from a brain perspective on the front end. And 35 years ago, it was a lonely club, I have to tell you. I joined a group called the Institute for Functional Medicine, and that you're very familiar with, of course. And there was a committee of the neurology section of that. And I was the chairman of that committee, the vice chairman, the secretary, the treasurer, and the only member for a long, long time, until I guess Terry Walls and Dale Bredesen came along. And it's still a pretty darn small group. But I think the research going on around the world really now makes it very, very clear that our metabolic factors, inflammatory factors, influenced, nuanced by our lifestyle choices, play a huge role, more so than in the heart and in the bones and in terms of cancer risk, in the brain. And what an empowering message that is. And that, really became I think the focus for every book that I've written over the years. We explored gluten and high carbohydrate refined diet back in the grain brain days. Now the term ultra processed foods has come into vogue. We didn't have that term back then, but basically that was the focus of grain brain. And then in Brain Maker, the idea that was way out there that the microbiome, in other words, the bacteria living within the gut could influence brain health. Wow, that was really raised a lot of eyebrows back then, of course. Now it seems self-evident, right? But everything that I've studied ultimately became clear to me converged on the immune system in the brain. And that epiphany happened around, I guess, 5 or 6 years ago, that we realized that the lens that we should be looking through to understand why it is that a high refined carbohydrate diet, that changes in the microbiome, that higher levels of cortisol, that imbalance between the sympathetic and parasympathetic nervous systems, which we know present a significant risk for dementia, all converge upon the brain's immune system. And really, those inputs decide whether our brain immune system is going to be supportive or destructive. We call supportive the M2 microglial cells and destructive the M1 microglial cells. That's it. So this understanding of the central role in what makes a good brain go bad, or what keeps the brain on track for the rest of your life, is really the convergence for me of everything I've been talking about. So it's I hate to give that a sense of finality in my life or in my academic pursuit, but I like it because it really connects all the dots that have been so valuable for me in understanding, again, why people develop neurodegenerative conditions, as we look through the lens of these microglial cells that can be either friend or foe, with the idea that we can control that. Then everything, first of all, makes sense. And number two, we are incredibly empowered to make better decisions to, again, chart our brain's destiny.
Empowerment really is the goal here, right? That we want to show people that there is a way through, and we don't have to succumb to the diagnosis, and we can be the purveyors of our own destiny. I think that's really, truly the goal here. Sorry, JP, I didn't mean to cut you off there. I want to quickly ask, though, Dr. Perlmutter, you mentioned microglial cells, and I know that I was at a really recent talk that you and Austin, your son, had a fun little debate on stage, if you remember, at the PLMI conference I believe it was last October. And you had this fun debate of microglia versus astrocytes and the two types of major immune cells that are present in the brain. You've discussed this, that you lean more towards the microglial side, your son leans more towards the astrocyte, and we know that they have to work in conjunction with one another. I'd love to talk a little bit about, and you've mentioned this M1, M2 situation, which is something we talk a lot about. The whole concept here is immunometabolism, right? What type of metabolism is occurring in these immune cells, which then dictates whether it goes to destroy destructive M1 state or into supportive repair fix state, which is M2 in the microglial cells. Let's discuss how microglia and astrocytes interact with one another and engage in creating a healthy brain where we can think clearly and use our brain more effectively.
Let's unpack that term immunometabolism, because it's a bit de rigueur these days, and it relates to seemingly disparate systems in the body, the immune system and metabolism as a fundamental part of what keeps a cell going, keeps us going. And the reality is that the metabolism of these immune cells in the brain dictates whether they are going to be brain defenders or they're going to become the evil twin. It is based upon their metabolism. And metabolism is a bit of a broad term, not only encompassing energy production from cells, but also how cells are able to manufacture proteins from raw materials, how they handle fat for manufacturing important molecules, and even for the utilization of fat for fuel. But by and large, I think the most important context, at least in the realm of immunometabolism that we're looking at, is energy production via the mitochondria, something you've talked about on your podcast quite a bit. And the major shift that happens with the shift of the microglial cells from being friend to becoming foe is a shift in their metabolism away from reliance upon the energy produced by their mitochondria. We know the mitochondria, these energy producers, that is a bit narrow in terms of defining what they do. We could talk about a lot of what they do today, aside from energy production. But in the context of their metabolism, they're making these energy molecules called ATP when they're in the supportive brain defender M2, what we call phenotype or configuration. When they shift to the damaging evil twin M1 configuration, their metabolism shifts. And the shift from M2 to M1 changes their metabolism, but importantly, a metabolic shift within them can also shift them. So anything that affects the metabolism can also bring about the shift. They can shift from M2 supportive to M1 destructive by virtue of being exposed to inflammation, exposed to bacterial components, exposed to trauma, and then secondarily, their metabolism can shift, or the mitochondria can be targeted. If the mitochondria are targeted, they will shift as well. So when this metabolism is shifted away from this hyper-efficient ATP production from the mitochondria to a different form of energy production, a change in their metabolism to something new called glycolysis, that is how we characterize then this M1 microglial cell. And I want to say, because I think it's important, that I tend to characterize this M1 microglial cell as the evil twin, the destructive form. But there is a time and place, there are circumstances in which this M1 microglial cell does some good things acutely in the face of an acute challenge, an acute trauma, an acute bacterial infection, etc. We need to be able to have those M1 microglial cells do the things that they do to help us wall off infection, deal with the bacterial components, provide energy in a very short burst. But the key is to be able to limit that response. And that's why we want to be able to bring an end to these responses once they are no longer necessary. And this is a central theme of the book, being able to revert those microglial cells that have shifted to becoming the M1 form back to being supportive, to nurturing our neurons, to enhancing the health of our synapses, to actually shoring up the blood-brain barrier. That's what these loving, nurturing M2 microglial cells do and why we desperately need them. Because when we stay in the M1 form, we are continuing the damage. We're propagating the production of more and more inflammatory chemicals called cytokines, which then feed back and convert more and more of the helpful M2 microglial cells like zombies into the M1 form. We've got to limit that. The limitation, how we do it, is through their metabolism. And here's the keys to the kingdom. The metabolism of the microglial cell mirrors body metabolism. So whatever we do to keep our metabolism on track, in other words, keeping our blood sugars normalized, keeping our insulin sensitivity where it needs to be, maintaining good body weight, maintaining a good waist to hip ratio, keeping our blood lipids intact and our triglycerides intact and our blood pressure intact, all of the metabolic markers that we want to really address via our day-to-day lifestyle choices are looked at by our microglial cells. So in a very real sense then, what I've just done is connected our lifestyle choices to our brain's destiny, the whole thesis of the book, based upon keeping our metabolism in check. And the statistic that you are all familiar with, that somewhere around 94% of American adults has at least one, but likely more, issue with respect to metabolism being out of whack, it sets the stage then for our microglial cells to not be able to function appropriately and explains why we are seeing such a dramatic rise in neurodegenerative conditions. These are, dots that are now connected through the lens, as I indicated earlier, of these microglial cells. such that we really get it now. We get it why, there's a relationship, and we'll talk about it, I think, later, between consumption of ultra-processed foods and risk for Alzheimer's disease. Well, how the heck does that work? And it works through its connection of the metabolism of the microglial cells.
Yeah, there's this connection between metabolism and inflammation and other signs of aging, things like the depletion of NAD+, the dysregulation between AMPK signaling and mTORC1, so nutrient sensing, all of which sort of feed into this. What I really like Navio's discussion of the cell danger response. And I think what we're talking about here is all of those lifestyle choices and all of those environmental factors that can drive the immune cells in our brain, the microglia, into that, angry M1 state. All of them are really being interpreted as threats. So the immune cells are there to protect the brain. They're encountering these influences, whether they be ultra-processed foods or lack of sleep or stress, and really they don't differentiate between any of those. They just respond with inflammation. And they do that, and as you said, when they move into that inflammatory state, they trigger this cell danger response. And the very first thing that happens in this cell danger response is a shift in metabolism. You see an increase in the production of reactive oxygen species, a leakage from the electron transport chain, all of which is actually designed to protect the cell, because increasing the production of reactive oxygen species in those microglial cells is triggering the immune response within the cell to protect it from a microbial invasion or any kind of threat, because it wants to become an inhospitable environment. And so you're absolutely right. And my personal bias here is that microglial cells are the most important cells in the brain. They're even more important than the neurons. And the reason why I say that is because they were there first. During gestation, you talk about neurodegenerative diseases. I also think about the role of microglial cells in neurodevelopmental conditions and the role that they play in building the brain. They are literally the architects and the builders of the entire network that ultimately results in thinking. Yes, it's wonderful, but we have these immune cells to thank for it.
That's right. And, far be it from me to agree that, these are, in fact, I believe, the most important cells in the brain. I think the neurons are the workhorses, and yet the neuron has been the center of attention, since Ramon y Cajal, we're talking about, over a century that really everything is focused on the neuron. And the neurons are really kind of the last to go in Alzheimer's disease, for example. It's not, the clinical manifestations early on in Alzheimer's have not a lot to do with the neurons. It's more the loss of synapses, which is a microglial immune-related destruction. It's the loss of connectivity at the microscopic level and the macroscopic level as well, as these individuals lose connection with themselves and with people around them. So you're very right. And you mentioned something I think is really fascinating, and that is the role of these microglial cells in neurodevelopment and then neurodevelopmental disorders. And I think what people don't realize is that, early on in our lives, we are forming synapses, connecting neurons at an incredible rate. In a one-year-old human brain, the rate of synapse formation is around 1 million new synapses or connections per second. That's a lot of synapses. But interestingly, those synapses are actually being destroyed by about 20% of that rate. It has to do with synapse destruction. And why would the brain be destroying the very synapses that it's creating? It's destroying them to refine and sculpt a more efficient brain. So this is called synaptic pruning, and we need a healthy level of synaptic pruning, which, as you indicated, is a microglial controlled event. Certain synapses that we don't need to have on board early on in life are tagged specifically with complement protein, C3 and C1q, and then the microglial cells sees these synapses with a signal on them that says, eat me. They come along and digest those synapses away, and that's a good thing. That refines the rough form into a more refined, more efficient, more high-speed kind of brain. And interestingly, two things. In neurodevelopmental issues like autism spectrum disorder, that rate of synapse digestion or removal is reduced. So these brains are hyper-connected. The other interesting thing to think about is that now we are looking upon Alzheimer's disease as a reactivation of this developmental process, such that for whatever reason, and we can unpack that, these microglial cells are attacking our synapses. And in a very real sense, it represents simply the same exact mechanism. These synapses get labeled with complement protein. The microglial cells see that as a signal, digest away the synapses. That's what we've got to focus on. And interestingly, the synapse is very rich in microtubules. And those microtubules are deeply invested with tau protein. And what makes them labeled for digestion is the fact that those tau proteins are phosphorylated, specifically one at the amino acid level of 217. So this p-tau 217 blood test that everybody's getting, because it's a marker of Alzheimer's risk or early Alzheimer's or rate of progression of Alzheimer's, all three of those last statements have been validated. It is because that p-tau 217 in the area of the microtubules in the synapse is being digested away and liberated, then finds its way into the blood, and we're able to measure that. So in a very real sense, p-tau 217 is a marker of synapse destruction and microglial activation. And I really want to get that point out because everybody's getting their p-tau 217s checked now. What is it telling us? Yes, it's telling us those three risk factors that we talked about. But from a mechanistic perspective, it's an indication of microglial cell activation. And the empowering part of that is, hey, we can bring the p-tau 217 back a bit, maybe to normal levels, who knows? But the real issue that's phosphorylating the tau to start off with, we got to pay attention to. It's not just like, oh, it happens because you have a you have APOE4, you're going to phosphorylate your tau. No, we phosphorylate tau in our APOE2 individuals, APOE3 individuals as well, who can get Alzheimer's, just like the next person. We do so when we are metabolically compromised. So let's relate metabolic dysfunction to this very important risk factor that people are very familiar with now, p-tau 217. And, for any of the viewers of this podcast who haven't heard of that, that would be something that you may want to consider getting and have a conversation with your healthcare practitioner about. It's one of the lab studies that I talk about in the book, Brain Defenders, because it's valuable. And it's valuable from the extent that it tells us the activation state of our microglial cells.
You raise the connection between neurodevelopmental and neurodegenerative diseases, and you talk about autism spectrum disorder. But the other condition that actually probably mirrors Alzheimer's and dementia and the loss of connectivity is actually schizophrenia. Schizophrenia is sort of, in my mind, sort of the polar opposite of autism. In autism, as you correctly point out, there is a deficiency in neural pruning or synaptic pruning. So you end up with a hyperconnected network. In schizophrenia, you have the opposite. You have this pruning activity that becomes sort of out of control, and there's too much of it. And so you lose synapses, you're losing the connectivity, the careful listening that these microglial cells are supposed to be doing. I mean, they spend 94% of their time actually monitoring synaptic activity when they're in their M2 state. When they get dysregulated, they start to chew through those synapses when you need them. And so that's a lot of the medical developments and pharmaceutical developments for schizophrenia are viewed as having potential in treating Alzheimer's and dementia. So I think there's no question that these microglial cells are at the heart of how we're going to ultimately treat these conditions. But you mentioned also apolipoprotein and the role that it has in ultimately tauopathies and triggering a higher risk for getting dementia. I'm currently now studying and looking deeply at the role of the glycocalyx. And we think of the glycocalyx when you think of, things like atherosclerosis and the breakdown of the barrier that prevents the LDL from getting into the vessel wall. But the same thing is happening at the microvascular level in the brain. And so part of that trigger of how, apolipoprotein and LDL infiltration into the parenchyma, how that can lead to inflammation and oxidation and ultimately, tauopathy. That's a piece of this equation that I don't think gets a lot of attention, is that in many ways, that initial seeding of damage mirrors what you see in atherosclerosis. And in fact, you can call dementia and Alzheimer's really at the beginning stages not that different from microvascular disease.
Oh, I completely agree with you. I got an invitation from a Dr. Mark Houston to give a talk last year on it was called I think it was the heart-brain connection, but I think I prevailed and made it the brain-heart connection. You know how that goes. No, I don't remember how it was connected, but and Mark has done a lot of work over the years on the glycocalyx, targeting the glycocalyx in heart disease. And you are right. I think at least half of what I talked about was the important role of a healthy glycocalyx, because it makes up, a significant part of the actual blood-brain barrier. And recognizing that the glycocalyx is highly responsive to metabolic inputs, either pro or con, really, I think, does exactly what you just described, forms a powerful relationship, an understanding of the relationship between heart disease and brain disease in terms of similar mechanisms, beyond the fact that the heart is connected to the brain, physically and certainly chemically and absolutely electrically. But that said, I think that there's not a lot of attention with respect to the glycocalyx, and there should be, because it's amenable to repair by a lot of the techniques Dr. Houston has described, the nutritional techniques, even pharmaceutical techniques. I think the biggest inroad for improving the glycocalyx and its functionality, upon which we really depend both in the heart and the brain, is really targeting underlying metabolic issues, because that's what is most important in terms of being a threat to the functionality of this glycocalyx. And when you look at the electron microscopy of what the glycocalyx looks like at the blood-brain barrier level in health versus disease, I think it's quite remarkable. So I made slides, to show to audiences what a healthy versus non-healthy glycocalyx looks like. What does the glycocalyx look like in the compromised brain? And it's pretty dramatic and correlates quite well with what we see in the coronary vasculature. So that's actually a very, very valid point, very important point.
Yeah, there's a technology called the GlycoCheck, which I don't know if you've used it.
I have.
It seems to me like something that is currently being marketed and focused towards cardiovascular disease.
It is.
But it's just as valid for looking at neurovascular and ultimately, vascular dementia risk. You're right. This glycocalyx, which is this network of strands of glycoproteins and proteoglycans and the like, that serve as this polar barrier to prevent the influx of LDL particles and other particles into the endothelial layer. That's really the protective barrier that we're looking for. It's susceptible to metabolic damage, reactive oxygen species from within, and then because it literally grows out of the endothelial cell. And so when you have high levels of reactive oxygen species in metabolic dysfunction, mitochondrial dysfunction, you see a breakdown. And you can actually have a blood test that will test to see how much of this is being shed into your bloodstream. I think these are incredible tools, along with obviously tau measurements, et cetera, that I think should be deployed widely, because the value of testing early while it's reversible is so critical. And we talk about wanting a cure for Alzheimer's, but what we really need is something that delays its onset by 15 or 20 years.
Or it keeps the onset from even happening. That's exactly the brass ring for me, because I think that's achievable. And I know that we're in the weeds a little bit, but I kind of thrive in the weeds. And so I'm still at the glycocalyx, because if you look at the cross-section image, which is why we make slides, some of us make slides because we'd rather see images as opposed to text. And you look at that and you see on the endothelial cells are lining the vasculature. And within them, you see this glycocalyx, extending itself into the vessel itself to monitor what's going through. But juxtaposed on the inside of those endothelial cells are microglial cells. They are responding and getting signals from the environment that's transmitted through this blood-brain barrier. What's the state of health here? What should I be doing? How can I respond? So as we degrade via not having a healthy glycocalyx and allow increased permeability of the blood-brain barrier, now we are allowing various molecules and other components, viruses, bacterial components as well, to make their way across this blood-brain barrier to then polarize our microglial cells away from being supportive. This all just makes so much sense. And, the greatest risk factor for degradation of this blood-brain barrier is our chronological age. And I take that back, actually. I'm going to say biological age, because it's time that we focus really on the idea that we should be using biological age. We have the easy technology now for measuring that. It's not the number. Your body doesn't really know how many times you've gone around the sun, how many birthdays you've had, but it sure as heck knows what are those epigenetic influences on your gene expression that are easily measured via methylation clocks. And I think that there was actually an interesting report in New England Journal recently saying that it's time that we abandon chronological age in terms of both research and in terms of our outgoing messaging with respect to any type of therapy, that this is what the dosage or, that we should be using a particular drug in people between 50 and 60 years old, and it changes in, when you're over 80, whatever. That makes very little sense, because we all know there are plenty of people walking around in their 70s who are in tough shape, and others who are in their 70s and can be able to carry on, a very meaningful, in-depth conversation about whatever the topic may be. So I think it's absolutely time that we use biological age, post-chronological age.
Cancel all the birthday parties.
Yeah, and and then that becomes a goal. I want to segregate my chronological age from my biological age as far as I can in the right direction. Let's be clear, which we know we can do.
That's the definition of longevity and extending health span, isn't it? Like that
absolutely
we don't
is.
follow the exact same trend as our chronological age, but we push it out further so that we can live longer or live as healthy as we can as long as possible.
That's right. And let's stay in the weeds a little bit longer. I don't know, maybe for the rest of our time together, because it's just so much fun. And I know you have viewers who fancy themselves as biologists, molecular biologists, want to get into this. And so there's one thing, JP, that you had mentioned earlier, and that is, this down regulation or even overt destruction of the mitochondria that can be induced by stress, can be induced by toxic exposure, you name it. And toxic exposure being certainly a big issue these days as it relates to certain environmental toxins that are seemingly ubiquitous, like paraquat and glyphosate, for example, which are clearly associated with increased risk of Parkinson's, for that matter. But interestingly, when mitochondria are damaged, that's a big event. Not only are we compromising energy production, which will polarize our microglia away from being supportive, but when mitochondria are damaged, they ultimately will release their DNA. And okay, they got damaged, they blew up, their DNA got ejected. That's a terrible thing. Well, that DNA isn't just going to be digested away and form whatever, amino acids or nucleic acids, rather. But that DNA is a cell signaling mechanism. That DNA is sensed by the microglial cells as something going wrong. It becomes a damage-associated molecular pattern, which the microglial cells interpret as something going on, and therefore we're going to shift to M1. Well, why would mitochondrial DNA be a damage-associated molecular pattern? Think about it. The microglial cells are primed for sensing all kinds of things. For example, like bacteria. Bacterial DNA, for example, when liberated, will polarize our microglial cells away from being supportive brain defenders to being destructive. Well, what is mitochondrial DNA? Think about it.
No,
Bacterial DNA, right?
it's bacterial DNA. I mean, it's
Uh,
it's
Lynn
a simple.
Margulis made that very clear to us, or Margulis. And it is bacterial DNA. That's what its origin is. And our microglial cells sense that as bacterial DNA. So then they go into this attack mode, the M1, which again may be appropriate in the short run, but we've got to limit it. And this limitation of the microglial cells being in their powerful defensive posture is really very, very important. It explains some things. For example, when you take a look at a large number of individuals who've had head trauma, a large enough group of individuals such that you can make inferences about variables. And what you find is that individuals who have an underlying metabolic issue like type 2 diabetes have a worse outcome and a more prolonged hospitalization, a more prolonged convalescence. Why? Well, we've all had head trauma. Why are the diabetics doing worse? Because with this metabolic issue, their microglial cells can't revert back to being in a state that allows them to regrow brain cells, to enhance synapse production, to shore up their previously damaged blood-brain barrier. They're stuck in damage mode, not in repair mode. We need the damage response acutely, but after just a few days, when the free radicals have been mopped up, the inflammatory issues have been mopped up, et cetera, we need to be in repair mode. And that doesn't happen as readily in people who are metabolically compromised. So there's a lot to be said about why we got to do everything we can to keep our microglia in their M2 configuration and help to push them back once they've shifted to the dark side.
Yeah, and that state of being in that mitochondrial dysfunctional state that you're talking about, where there's reactive oxygen species that are being produced at prodigious rates. It's damaging the mitochondrial DNA, the bacterial-like loops of DNA that are sitting inside the mitochondria, inside the cell. Yes, they eject their DNA. That triggers an inflammatory cascade, including cGAS and STING, and the whole upregulation of cytokine production within the cell. And then the cell might undergo apoptosis, and now you've got all the contents of that cell sitting out in the extracellular space. And as you said, now that DNA gets seen as, hey, that's a bacterial invader. We have, as microglial cells or as immune cells, have to get activated. But it all basically starts, as you pointed out, and I think is a core feature of your book, is it all starts in those mitochondria. And the question is, how can we, as you said, when those mitochondria get dysfunctional and they're creating all these reactive oxygen species, how can we calm them down? How can we bring them back into a state where they'll either repair themselves or reproduce to diffuse out the risk of damage by creating new ones? We call it biogenesis, new mitochondria. And there's some great supplements and things that we can do. Obviously, intermittent fasting and exercise are wonderful, but there are some really great supplements out there that I think, unfortunately, in the general population get sort of poo-pooed as witchcraft or woo-woo. But there's a lot of really important science that backs it up. Things like urolithin A, or the alternative charge mobility carrier of methylene blue. One of the things that happens that causes those reactive oxygen species to be produced at those rates is a loss of integrity at complex 1 and complex 3. So if you can carry those electrons, because this is what we're talking about, carrying the electrons across from complex 1 all the way to complex 4, if you can do that without leakage, well, then you're reducing reactive oxygen species production. And that's what methylene blue does. So, when RFK Jr. gets, there's spy cameras looking at him taking a little eyedropper and putting methylene blue in his drink, he's doing it for a reason. That's not witchcraft. That's hard science that he's employing for himself.
It's a very good point, and I'm just going to show you. Here's the cover, and we're really getting down into the weeds. Methylene blue is in the book. Urolithin A, obviously, I'd include that because I think what you're saying is so valuable that the upstream event, ultimately, even upstream of our microglia, is the mitochondria and the function of the mitochondria. So in a very real sense, that's the real keys to the kingdom, that is targeting our mitochondria. The biggest levers to pull for mitochondria aren't higher levels of coenzyme Q10, NAD precursors, methylene blue, urolithin. The big levers that we can pull right now are things like some of which you mentioned, time-restricted eating, fasting, and exercise. I mean, you alluded to AMP kinase earlier, but we want to do everything we can to both rid our cells of defective mitochondria and allow mitochondrial biogenesis to occur to grow new mitochondria. And here's what is really exciting about that the brain is able within its cells to share mitochondria between various cells when certain cells have defects in their mitochondrial function. And this happens through the production and utilization of these mitochondria of microtubules. So that's the transfer mechanism from one cell to the next of mitochondria. There is even some discussion that mitochondria can be shared throughout the body as well.
The heart.
But again, I want to emphasize for your viewers that while we're really getting down into it today, because we love doing that and we're kind of satisfying ourselves, I think the message that I put forth in Brain Defenders, what I always try to do is make what we are talking about much more understandable to the general population, because people don't need to know about PGC1 alpha or the real functions of AMP kinase or the NLRP3 inflammasome. Great. If you're going to take the quiz, you probably need to know that once. But the reality is, the take-home message is that your brain's health and function depend upon the state of your microglial cells, either friend or foe, that is influenced directly by your day-to-day lifestyle choices. You bet I go through all the supplements, the CoQ10, the urolithin A, the types of oil, why we need DHA, et cetera, why we need to have omega-3s to support cardiolipin as the platform upon which those electrons are indeed transferred in our mitochondria. Yes, we go through it all, but I want to be sure that people aren't off-put by the fact that we are having fun today.
I want to ask a question about the cause of some of that mitochondrial dysfunction. You've mentioned metabolic disorders and metabolic dysfunction being a major cause of it. I want to take a step even further back, because we do know that ultra-processed foods, biochemical sources of stress, are these major, most commonly known sources of dysfunction and causing blood sugars to go up. Have you been able to discover or see any particular other types of stressors as well as playing an important role here? Any psychological stressors that people may have experienced in the past that maybe primed those microglial cells into an M1 state more readily? Anything from a physical perspective that may play a role here? What other triggers can cause dysfunction to occur through the path of metabolic dysfunction?
I think that there are a lot of things like we could be talking about here. I think, let me play into your hand for just a moment. And I think that we are really getting to the point that the balance between our parasympathetic and our sympathetic nervous systems is hugely important and relevant as it relates to everything we've talked about today, including mitochondrial function. That, the direct relationships, one study that was performed in Taiwan that looked at, I think, 575 individuals, followed them over, I think, 15 years, and looked at where they ranked on heart rate variability, which is, let's say, a marker of parasympathetic versus sympathetic balance in the body. And they found that, a very, very strong relationship between lower levels of heart rate variability, in other words, lower levels of parasympathetic activity, and risk for dementia. So we know that plays directly into everything we've talked about. Food, what could be more important? One study that appeared in the Journal of Prevention of Alzheimer's in January of 2025. Think about that. The Journal of Prevention of Alzheimer's. Whoa, did I die and go to heaven? What has happened here? But anyway, this study looked at 1,375 individuals, followed them for 12.7 years. And what they found was they followed these people in terms of what did they do cognitively over that period of time. And let's look at your food frequency questionnaire. And what they found was that as an average, one serving per day, as an average, of ultra-processed foods, and they define what that means, some on the list were a little surprising, like flavored yogurt. But 1 serving per day increased risk of developing Alzheimer's disease by 13%. Having 10 or more servings per day increased the risk for Alzheimer's by 2.76-fold, almost 3-fold increase risk for disease for which there is no real pharmaceutical treatment today. That's huge. And so, the big push now to identify and label ultra-processed foods as being dangerous, I couldn't support more. We don't have any pharmaceutical treatment for Alzheimer's today. As a matter of fact, about a month ago, a Cochrane analysis was published that evaluated 17 studies of these drugs that had been FDA approved that target beta amyloid. These are the common drugs now that neurologists are giving intravenously to get rid of beta amyloid in the brain. This Cochrane analysis of 20,375 individuals, 17 studies, 18 months per study, found that these drugs that did very well in terms of getting rid of the beta amyloid in the brain actually had no meaningful clinical response. The term that they used in the Cochrane analysis was trivial. Yet, these drugs are associated with significant side effects in around 25 to 28% of individuals, like bleeding in the brain and swelling in the brain. So, the idea that getting rid of the amyloid in the brain is the answer has been proven to be categorically wrong, which categorically tells us that beta amyloid is not the cause of Alzheimer's disease, or if it were, then getting rid of it would be, hey, problem solved. That's not where we are. So in looking at the microglial cells and inflammation and metabolism, we are way upstream in the headwaters of what makes a good brain go bad.
Yeah, I was just going to drive home the point and agree with you that amyloid beta, and specifically amyloid beta 42, which is the size of the chunk of the protein that's actually cleaved off, that forms the most sticky and toxic form of amyloid, which is associated with Alzheimer's and dementia. I think of it more like a symptom. It's not a cause of the disease. What's happening upstream. So, and just for our listeners, you've got amyloid precursor protein, which is called APP. And that's in everybody. Everybody has that. The question is, how are we going to dispose of it? How are we going to deal with it? And we have different enzymes that can cut it. And so APP can get cut. Most of the time, in a healthy individual, it's cut in a way that eliminates the possibility of amyloid beta being produced because it's cut in a place in that protein where it literally splits it in half. It can never form amyloid beta at that point. But what happens when you're inflamed and when your microglial cells are active and when your metabolic state is dysfunctional because your mitochondria are stressed, all of a sudden, a different set of enzymes start to cut that APP and turn it into amyloid. Now, the question is, why is that happening? Why is it that we're losing alpha secretase, so now we're using beta and gamma secretase to cut the APP? I know that that's getting into the weeds.
No, but there's an answer for that question.
That's the problem.
There's a very good answer for that question because it's a protective mechanism. The brain activates this alternate pathway as a way of protecting itself against microbial invasion. Because remember that the work of Rudy Tanzi at Harvard, that amyloid beta is an antimicrobial peptide. It is the enemy of my enemy, therefore my friend. Seems perverse with all the ways that we are targeting amyloid to get rid of it. But it's a response element. It's exactly what you said. It shifts how amyloid precursor protein is cleaved such that beta amyloid is produced to serve the brain, to help the brain deal with invaders, or at least perceived invasion, because the microglial cells now are sensing that something is wrong and secreting higher levels of inflammatory chemicals because they have shifted into their M1 configuration. There are plenty of Alzheimer's patients that don't have a lick of beta amyloid in their brains, and there are plenty of individuals who have lots of beta amyloid in their brains and are cognitively intact. Thank you very much. So again, I think it's time that we recognize this amyloid hypothesis as being nothing more than a hypothesis. It is not doctrine. It shouldn't be dogma. that amyloid is the cause of Alzheimer's, get rid of it, problem solved. It's been proven that that does not work. God bless the researchers for trying, but, Einstein said the definition of insanity is doing the same thing over and over and hoping for a different outcome. It's time that we move on. And what is really, I think, very encouraging is this shift away from the amyloid hypothesis to the idea that these microglial cells are front and center in terms of what makes a good brain go bad. Yeah, I happen to have written this book, but, I can't even imagine taking credit for this shift. I think, when the book is coming out now, people will become more aware of it. But, I say that these researchers who've been dedicating for the past decade to this idea that this is where the real problem is, man, they have done such incredible work, especially as it relates to considering, A, what makes these microglial cells shift from being supportive to being destructive, and B, what can we do to bring them back? And, to be fair, there's a lot of work demonstrating how lifestyle factors are important, can be leveraged to bring them back. And there's work in the pharmaceutical arena as well, and the technological arena as well, to target the microglial cells. There's a wonderful researcher, Dr. Lee Wei-Tsai at MIT, who's demonstrated that simply 40 hertz light and sound, the company is called Cognito, can help reestablish a normal background rhythm in the brain called gamma oscillation, and that reverts the microglial cells back to being supportive. Oh, that's not even pharmaceutical. There's not a downside here, a pharmaceutical downside. But to be fair, there are pharmaceutical approaches to target mitochondria for exactly the reasons we talked about, and to transplant microglial cells into humans and transplant mitochondria for that matter as well as target these receptors on the microglial cells, like the TREM2 receptor, to help keep it in the M2 configuration. So I am, I guess you could tell, 2 cups of coffee in. No, I am really excited for what the future holds by realizing we were going down the wrong path, turning around, coming back out, now exploring a new pathway, which is the brain's immune system, as really opening us up to the opportunity to help not only the 7 million Alzheimer's patients in America, but for the countless millions who are going to be afflicted moving forward. It doesn't have to be that way.
Let's shift to talking about some of the things that we can do to prevent and improve the function of the mitochondria, maintain that M2 state as much as possible within those microglial cells and macrophages throughout the body, and talk about things like exercise and shifting diet and stress management techniques. I'd love to hear your take on what are the biggest, highest leverage tools that are available for us to help regulate blood sugars, shift immune metabolism, and lean towards creating this shift towards longevity and health span.
Well, there's one lever that I think is the most important thing that anyone can do. And it ranks above everything you just mentioned. And it is to first embrace the idea that you're in control of your brain's destiny. Because if you don't do that, then the other things aren't going to happen anyway. So that's step one. And that's my plea. Because, the three of us have talked about the fact that, when things start going south, it's much, much more difficult. So in a very real sense, I'm hoping that 30 and 40-year-olds who are watching us right now are getting this message that that's the time then to begin implementing the lifestyle changes to rein in metabolism, reduce inflammation, paying attention to the gut wall integrity of all things. We know that feeds into inflammation and affects the brain. So I'm not going to invent anything that you haven't talked about before, because I'm going to emphasize things that you've talked about before. Getting enough sleep, metricizing your sleep, making sure that you're getting enough deep sleep so we activate our lymphatic systems to help the brain remove the garbage, as it were. Emphasizing exercise. JP, you talked about activating AMP kinase. We can unpack that, but let's just say exercise in the context of targeting mitochondria and therefore our brain's immune cells. Diet, fundamentally important. We've got to keep insulin functional. We've got to keep our glucose levels in check beyond just being so-called normal range. We've got to keep our glucose in the optimal range. Check your fasting insulin level once in a while, not just your blood sugar level. Fasting insulin predicts where your your blood sugar is going to go in years from now. Yes, look at your A1C as well. I list a variety of not really exotic, but important blood tests that people can get. But as it relates, again, back to the diet, again, controlling blood sugar is critically important. I put some important bullet points in the dietary section to make things actually simpler. I want to control blood sugar. I want it to be a plant-forward diet. You can eat, animal products if you choose, and I do, but mostly plants. It needs to be colorful so as to nurture the microbiome and contain higher levels of polyphenols. And pretty much that's it. You've got to have enough protein to build muscle because muscle is the body's pharmacy to make certain chemicals that actually make their way to the brain and do good things. But, the big levers with respect to diet are diets that keep blood sugar under control, that have fiber, are colorful. And, there are so many diets out there right now. There's Mediterranean, Green Plus Mediterranean, paleo, not so paleo, primal, you name it, right? Carnivore, etc. So I drew a very broad stroke approach to what I'm recommending from a dietary perspective to make it easier. May not be as easy as you think. If you start doing a continuous glucose monitor and measuring the things that we recommend in the book, you'll see that, maybe your diet isn't where it needs to be in terms of controlling your blood sugar. I really believe that and making sure there's enough dietary fiber rich in polyphenols, that's job one. That's the biggest lever to pull. There's some great, what I call superfoods to add to your diet. I even talk about broccoli sprouts and how to sprout broccoli seeds because we want to amplify sulforaphane. Broccoli sprouts, we chew them, we liberate sulforaphane from the glucoraphanin. I talk about something you're familiar with called Himalayan tartary buckwheat as being a powerful polyphenol-rich type of superfood. And again, that targets now with research that's been published and an ongoing study being published soon, that targets our biological aging, which I think is hugely important as it relates to these microglial cells. So we've talked about exercise, we've talked about sleep, we've talked about diet. That's pretty much it. Those are the big levers that we can pull. I think stress management is really important. I think anything we can do to become more parasympathetic and downregulate our sympathetic lives, because we all know that there is every opportunity for our sympathetic nervous systems to be activated day in and day out in the modern world in which we find ourselves. So everything we can do to increase parasympathetic activity, I think, is going to be helpful. Things like vagus nerve stimulation, things like Apollo Neuro device that helps us do this, help us remain more in a parasympathetic state, and meditation as well. So there are a lot of things, most of which are pretty straightforward and not really intensive in terms of buying equipment, etc. Yeah, if you want to go that route, you can get a 40 hertz light. I have one. I wear the Apollo Neuro device. I do use the continuous glucose monitor, but I'm not the youngest kid on the block, so I got to ratchet things up a bit. I'm 71, and I'm hoping to preserve my cognitive function for as long as my body holds out. So, yeah, and I have a family history of Alzheimer's as well. So, I get the message, and I know that I also think it's important to walk the talk, so to set an example.
As you look forward to the future and say, these are the things I'm most excited about that are coming down the line. They're not here yet, but I see them as having the most impact for the future. I know for myself, I look at things like we talked about, and you mentioned mitochondrial transplant, some of those technologies. The one that captures my attention the most is this potential for partial reprogramming, the actual reversal of the epigenetic drift that we all suffer from as we age and as we encounter all the different challenges in our lives. Many of the things we've talked about, mitochondrial dysfunction, NAD depletion, AMP kinase loss of signaling, all of these different things are fundamentally reversible. We can do things to make our mitochondria better. We can do things to restore the level of NAD plus in our bodies. It's that epigenetic drift that locks those bad changes in. And the idea of getting that reversed and being able to shift those damaging marks back to where they should be, back to where they were when we were 20, is so fundamentally exciting to me. I'm just wondering whether or not there's anything out there that has that, or maybe it's that for you also. But I mean, is there anything out there that you just say to yourself, when that comes along, it's going to be the game changer?
I can't say what will be the thing, or what do I rank as, as top of list in 5 or 10 years. I think we're all following the reprogramming work of David Sinclair very closely, what he's been able to do using 3 of the 4 Yamanaka factors, and know that there is a clinical study ongoing in humans out of the country right now for a particular visual issue. We'll see where that goes. And the idea of mitochondrial transfer, I think is very exciting. I had Elizabeth Parrish on my podcast talking about gene therapy, actually, and she's undergone gene therapy. She describes herself as the first GMO human, having had the injection with adenovirus vector of specific genes. That holds huge promise as well. Beyond just, the idea of having something available for, a spinal muscular atrophy or some genetic issue that we're trying to repair, something that's obviously going to be a lethal situation, to being more nuanced about it and correcting genes that, have a sort of disfavorable long-term outcome, or even, try to go for a much more positive outcome. So there's a lot of things that we're all aware of. And I don't know that there's a finish line. We're hoping who gets there first. I think, primum non nocere, above all, do no harm. I have a whole section in the book talking about the potential of GLP-1 agonist drugs to be beneficial for the brain. Primum non nocere, above all, do no harm. We don't know long-term outcome in terms of the use of GLP-1 agonist drugs. Having said that, we do know what the long-term outcome is in patient diagnosed with Alzheimer's. It's a lethal disease. Therefore, I actually am supportive of the research studies going on, looking at using GLP-1 agonist drugs for the treatment of neurodegenerative conditions. In April of 2024, a study was published in the New England Journal of Medicine looking at 154 patients, following them for 1 year, randomized to receive a placebo injection or a lixisenatide GLP-1 agonist drug injection. And what they found was really quite extraordinary, and that is that in the placebo group, as expected, over the 1 year time period, this group declined on the Unified Parkinson's Disease Rating Scale, a standardized scale. And we expect patients with Parkinson's, unfortunately, to decline in their functionality over time. The group receiving the GLP-1 agonist drug, which targets mitochondrial function, I might add, actually not only stabilized, but slightly improved. Holy Toledo. It's been demonstrated once before. We actually did a study many years ago using intravenous glutathione, which similarly targets mitochondrial function, and published that double-blind placebo-controlled trial in the journal Movement Disorders, very small trial at the University of South Florida. But that said, we're starting to look at ideas that target the fire, not just the smoke. In other words, the underlying issue, not just the manifestations. So there are many inroads. You mentioned a few that then I unpacked a little bit. Well, I'm involved in a project right now to create a clinic that will be floating, and it'll be launching. It's going to be the largest residential passenger ship ever built on the planet, called Pegasus. People can go to Pegasus Residential Ship and learn about it. And the main focus of being a resident on Pegasus is going to be to have the ability to avail yourself of these leading edge types of therapy and diagnostic technology, leading edge. There are a lot of interesting ways of studying a human being well beyond what's available here in America that have great meaning. When we look at the epigenome, we look at the microbiome, we look at the metabolome of the microbiome, we look at certainly the genome and run that through the ability with AI to make, ultimately recommendations for an individual based upon his or her predispositions, not necessarily genetic determinants. That's what we've got to really realize, even as it relates back to this APOE4 predisposition. When you carry the APOE4 allele, you may have been told that Alzheimer's is your destiny. That is unfair. When you look at the Pointer study that was published in the Journal of the American Medical Association in 2025, what did they find? They studied 20,111 individuals for, I think, 12.7 years. No, actually, that was a shorter study. That was a 2-year study. So they studied 20,111 individuals over a 2-year period. And they had 2 groups of people. One group got a really aggressive intervention. What was the intervention? They met with them, I think, 36 times over the 2-year period, and hands-on talked about lifestyle in terms of your diet, your exercise, your stress handling, cardiovascular health, etc. The other group, I wouldn't call it a control group because they were an intervention group as well, got the information, but they only had 6 meetings. So they didn't really get the hand-holding. And what did they find? And this is why this is so important, because the study included people, 28% of American adults, American people, carry the APOE4 allele. This is why this is so important. What do they find? That not only did these individuals in the intervention, the big time intervention, 36 meetings, improve their cognitive function, and these people had metabolic issues at the front end of the study, but were cognitively intact and had no history of dementia or stroke. Not only did their cognitive function improve, it should have declined, but it improved, not just stabilized. These are people in their 70s, right? In the intervention, the big intervention group. But here's what doesn't really get talked about that I think is really quite empowering. That is I call it the non-intervention group. They got the information, but they didn't get the hand-holding. They improved as well. They didn't just stabilize. They didn't just stop their cognitive decline, but they improved as a group to a slightly lesser degree. But my goodness, that is pretty incredible. And this, again, included people carrying this APOE4 gene predisposition, not a determinant. So again, JP, to get to your point about the APOE4 people, they've been messaged over these years that, oh, you're in big trouble. You better get your affairs in order. Wow, that is so unfair. It really is so unfair. Look at this intervention and look what it did for them. So the idea that people shouldn't know their APOE4 status because, oh my gosh, you're condemning them, I think we should rewrite that narrative a bit.
This leans
100%.
heavily towards education and empowerment being the major ways to create change, because ultimately the onus lies with the individual on the changes that they are able to make. And if they feel empowered and are given correct or clean education that provides them that opportunity, more often than not, they're going to make those changes and see these improvements occur. And so that is so important for people to understand that. And I love what you said earlier, that big lever is knowing that it's not your destiny, that genetics are not your destiny, that because you have a diagnosis or you have a drive in a specific direction, that you are not, you don't have to go down that path. You have a choice. I think that's huge.
Yeah. And you said something, you said the onus, your words, the onus is on the patient. I get that. But I mean, we're here to hold your hand through this. We're here to give you the information. That's what you do. You're giving out this information. That's what the term doctor means. It means teacher. Doesn't mean healer. You're not going to bring about the change. You're going to bring about the education and, your words, empowerment. And we're actually creating a very, very powerful AI-influenced website or platform such that people can interface with this day in and day out and get the guidance that they will need to pull this off. And I think that's going to be revolutionary in terms of, bringing the cognitive decline in those individuals to a standstill. And the tools are already in your toolbox. You've already got this. You might need to buy a new pair of running shoes or sneakers or a new sweatshirt, whatever it may be, but you've got this. And, I applaud the flipping of the food pyramid on its head. And some things going on with respect to messaging as it relates to health are not areas that I would resonate with. But the idea that people are being told to stop eating the ultra-processed foods, have more good fat in your diet, and by the way, protein seems to be important, and a more plant-forward dietary recommendation, man, that's going to go a long way. And this is not just here in America. That's a global issue. We used to call it the standard American diet. Then it became the Western diet. And now it's the global diet. The global diet is one that is favoring these ultra-processed foods. In America, 60% of our calories are coming from foods that are threatening our lives. So it's troubling. The World Health Organization is telling us that 60% that the number one cause of death in the world are the chronic degenerative conditions. And those are highly influenced by our lifestyle choices. So in a very real sense, our lifestyle choices are leading to the number one cause of death on planet Earth. So
we're choosing to kill ourselves.
Yeah,
which is
but unknowingly. I think unknowingly,
not intentionally. Not intentionally.
Yeah, I think it's based upon what the media is telling us. The foods to eat, and the idea that here's a monoclonal antibody to help you with your autoimmune condition. Well, why are autoimmune conditions skyrocketing? And it gets back to this term, immunometabolism, because our immune systems are going, wonky because of our metabolic mayhem. Bring metabolism back online, appropriate metabolism, and the immune system will absolutely follow suit. And we're not going to need to inject ourselves with the next monoclonal antibody that we see on television every evening in the evening news.
100% agree with you.
JP, any final thoughts?
No, this has been a fantastic conversation. I really appreciate the time you spent with us today. I'm very much looking forward to reading and passing around copies of your book. I think it's going to be a remarkable addition to the library of great works for people to learn how to take care of themselves.
Well, I appreciate that. I'm going to show the title one more time. Self-promotion, shamelessly. The website people can go to is actually, oddly enough, braindefenders.com. Who knew?
Wow.
So that's where there's all kinds of things that people get, gifts and discounts, et cetera, when they go to that website and buy the book. So there you go. Self-promotion.
That's wonderful. This episode is coming out right before the book comes out. So this is actually perfect timing, and we're honored to be on your tour here of getting this information out to as many people as possible. And truly, honestly, a wonderful conversation as always with you.
Thank you.
I want people to know that you can take this information, utilize it for yourself, and share it with 3 people who you think could utilize this information to upgrade their health. Thank you all for listening, and we'll catch you all on the next one.